Hello, my name is Daniel, and today we'll be going through the AMC 10B from the year 2024. So let's get started. First problem, in a long line of people arranged left to right, the 1013th person from the left is also the 1010th person from the right, and how many people are in the line? Okay, so we have a long line of people like that. Each tick is a person, and like this is some number of people. And counting from the left, the 1013th person, so this much here. So let's say it's this person is the 1013th person, is also the 1010th person from the right. So starting from the right, this much is going to be 1010 people, right? So how many people are in the line? Obviously, that's this much, 1013, plus this much, 1010, minus this one person, because he's counted twice. So it's 1013 plus 1010 minus 1, which is obviously 2022, and that is our answer, B. Number 2, what is 10 factorial minus 7 factorial times 6 factorial? Okay, so let's just factor out 7 factorial, right? So that's going to be 7 factorial times 8 times 9 times 10 minus this, which is 7 factorial times 6 factorial. So factoring that out, that's 7 factorial times 8 times 9 times 10 minus 6 factorial. If you're like me, you've memorized 6 factorial, that's 720. And if you don't know, 6 factorial is just 5 factorial times 6, right? So it's going to be 120 times 6, which is 720. But then incidentally, this is also 720, right? So it's 7 factorial times 720 minus 720, which is 0. So it's 7 factorial times 0 equals 0, and that's the answer. It's B. Number 3, for how many integer values of x is the absolute value of 2x less than or equal to 7 pi? Okay, so since the absolute value of 2x is less than or equal to 7 pi, that means 2x itself is between 7 pi and negative 7 pi, and dividing 2 from everything, we see that x is between negative 7 pi over 2 and 7 pi over 2. But then pi is like 3.14, right? So 7 times 3.14 divided by 2, and if we just do that, this is going to be equal to 21.98, right? Oh yeah, so it's barely below 22. This divided by 2, this is going to be less than 22 divided by 2, which is 11. So also this is going to be like this, negative 11. So it's basically become this, and this, and it is definitively less than, so it's not equal to. X is between negative 11 and 11. So this is from minus 10, minus 9, all the way, 0, 1, all the way to 10. So this is 10 numbers plus 10 numbers plus 0, which is 21. So 21 is our answer. It's E. Number 4, balls numbered 1, 2, 3, and etc. are deposited in 5 bins labeled A, B, C, D, and E using the following procedure. Ball 1 is deposited in ball A, balls 2 and 3 are deposited in bin B, the next 3 balls are deposited in bin C, the next 4 in bin D, and so on, cycling back to bin A after balls are deposited in bin E. For example, balls number 22, 23, all the way to 28 are deposited in bin B at step 7 of this process. In which bin is ball 2024 deposited? Okay, so if we have 5 bins, like that, A, B, C, D, and E, then we will have, first A will have 1 ball, B will have 2 balls, 3 balls, 4 balls, 5 balls. Notice that this is number of balls. So actually, ball 1 is going to be here, ball 2 and 3, so 2 balls are going to be here, ball 4, 5, 6, so 3 balls are going to be there like that, and that continues. So like 6 balls here, 7, 8, 9, 10, all the way. And then we want the number 2024 is deposited. So ball 2024, we have to find out 2024 is going to be 1 plus 2 plus 3 plus all the way to some number n, and then plus a little bit more. These are going to go in the bin in which ball 2024 is deposited, right? So first, to get this, we need the n for which sum is less than or equal to 2024, but the maximum possible n value of that, right? This has to be, so this formula is n times n plus 1 over 2, which is less than or equal to 2024, and we need the maximum possible n like that, okay? So seeing that, let's move that over here. Then that becomes n plus 1. This is less than or equal to 4,048, right? And since it's 4,000, so it's n is going to be between 60 and 70, right? Because 60, this makes 3,600, and 70 makes 4,900. And since it's 4,048, let's go for like, 63. So if n is 63, then 63 times 64, this is going to be 2016. Oh yeah, and that puts us right before 2024, right? So this means that n is 63. So it's 1 plus 2 plus 3 plus all the way to plus 63 plus, so this much is 2016, and to number 2024 we need how much more? Like 8 more, right? So what that tells us is that this is going to go in A, B, C, 4 is going to go on D, E, F, G, A, B, C, D, E, A, B, C, D, E, all the way up to 63, which is going to be right here, right? 63 is going to go in bin C, obviously, because each row holds, 5n plus 1, 5n plus 2, 5n plus 3, 5n plus 4, and 5n itself. 63 balls are going to go here, and the next 8 balls, which includes 2024, is going to be in bin D. It's D. Number 5, in the following expression, Melanie changed some of the plus signs to minus signs. When the new expression was evaluated, it was negative. What's the least number of plus signs that Melanie could have changed to minus signs? Okay, so first of all, we know that this whole sum, this is, okay, so how many numbers are there? There are 50 numbers, and I know this because all the odd numbers from 1 to 100, that's what this is. This is just 100 divided by 2, so this is 50 numbers, right? That's how I got 50, and so it's 50 numbers. So it's 50 squared equals 2,500. So 2,500 is the number, yeah, that's the sum. And we want the final expression to be negative. So we need to make this less than 1,250, right? So what we need is, if we have 1, 3, 5, 7, all the way 97 and 99, somewhere in the middle there's going to be like a rift where all the numbers here are plus and all the numbers here are minus. And we do this because we want the least number of plus signs to change to negative. That means all the negative numbers has to be big numbers. So since all these numbers are positive and all these are negative, that means that these have to sum to less than half of 2,500, which is 1,250, but closest, right? Let's say that if there are n numbers there, then this is going to be 2n minus 1. That's going to be the odd number that's here. And there's going to be n numbers over here. And so this is going to be n squared, right? And so we want the square number that is, so we want the largest square number that's less than 1,250. And if you see, 32 squared is 1,024. So 33 squared, that's going to be 9 times 121, that's 1,089. That's a bit lower than we want. Let's try 35. 35 squared, that's 1,225, and that puts us right below 1,250, right? So our n is 35, so that means of the 50 numbers that are here, 35 of them are positive, and what's 50 minus 35? That's 15. 15 numbers have changed to negative, so that's B. Problem number 6. A rectangle has integer side lengths and an area of 2024. What's the least possible perimeter of the rectangle? Okay, so for it to have the least possible perimeter, we want it to be closest to a square. And let's just prime factorize 2024. 2024, we can see that it's 8, and then it gives us 253. And we can see that 253 is further broken down into 23 and 11. Since these are both prime, we want to find out how to, distribute the 2's from here. And if you see times 2 here and times 4 here, that will give us 2024 equals 46 times 44. And that's the closest that we can get to a square. Because any closer is going to be 44 and 45. Sorry, 45 and 45, which, isn't even multiplying to 2024. So our perimeter is 2 times, these are our side lengths. So 46 plus 44 equals 180, and that is our answer. Number 7, what's the remainder when this whole thing is divided by 19? Let's factor out 7 to the 2024, right? So that's going to be 7 to the 2024 times 1 plus 7 squared. And let's just look at the inside. This is going to be 1 plus 7, so that's 8 plus 49, which is 57. That looks suspicious because 57 is 19 times 3. So this whole thing is divisible by 19. The remainder is 0, obviously. Number 8, let n be the product of all the positive integer divisors of 42. What's the units digit of n? Okay, so there's 2 ways to do this. First of all, since 42 is quite a small number, we can just list all the divisors. 1, 2, 3, 6, 7, 14, 21, and 42. And since it wants the units digit of n, we can just multiply the units digit of everything. So this is 2, 6, 36, so it's 6. 6 times 7 is 42, so it's 2. 2 times 4 is 8. 8 times 1 is just 8. 8 times 2 is 6. And you can get 6 like that. or there's a version that works for higher numbers. Prime factorizing 42, we see that 42 is 2 to the first power times 3 to the first power times 7 to the first power, and that means that we have 1 plus 1, 1 plus 1, 1 plus 1 is 2, 2, 2, right? So that's 2 times 2 times 2, which is 8 factors. And these 8 factors, 1, 2, 3, 4, 5, 6, 7, 8, are going to multiply to 42. Like these two are going to be multiplying to 42. These two are going to be multiplying to 42. These two will multiply to 42, and these two will multiply to 42. So, in essence, this gives us 42 to the 4th power, right? So, for the unit digit of that, we can just do 2 to the 4th unit digit, which is, what is it? 6. So, we can get 6 like that. Either way you get it, it's a valid option, it's D. Number 9, real numbers A, B, and C have arithmetic mean 0. Okay, so A plus B plus C over 3 equals 0, which means A plus B plus C is 0. The arithmetic mean of these three is 10. Okay, so A squared plus B squared plus C squared over 3 is 10. That means A squared plus B squared plus C squared equals 30, right? What is the arithmetic mean of AB, AC, and BC? Okay, so I'm looking at A plus B plus C, A squared plus B squared plus C squared, and these AB, AC, and BC, that should kind of trigger you to something, which is A plus B plus C squared, because this expands to A squared plus B squared plus C squared plus 2 times AB plus BC plus CA. And we can substitute in these values. Since A plus B plus C is 0, this becomes big fat 0. So it just, becomes 0. And because of this, we can replace these 3 with 30. So 0 is 30 plus this whole shingamajinga, So we can see that AB plus BC plus CA equals negative 15, because this goes away and we divide by 2 like that. We want the arithmetic mean of AB, AC, and BC. So this divided by 3 is this divided by 3 is negative 5, and that is our answer. It's A. Number 10, quadrilateral ABCD is a parallelogram and E is the midpoint of the side AD. Let F be the intersection of lines EB and AC. What's the ratio of the area of quadrilateral CDEF to the area of CFB? Okay, so we might draw a parallelogram like this, but see that there is no other restriction for the parallelogram, right? So any quadrilateral will give the same answer as long as it's a parallelogram. Why not have a square, Because it's, good to work with. A, B, C, D, like that. And E is the midpoint of the side AD, like that. F is the intersection of lines EB and AC. So EB and AC, we have AC like that. So this is F. And what's the ratio of area of quadrilateral CDEF? This thing to the area of CFB, like that. Okay, what we're going to do is, first of all, notice that this triangle AEF and CBF, they are similar triangles, and their ratio of similarity is 1 to 2, right? So this is 1 to 2. That means that this length to that length is 1 to 2, and this length to that length is also 1 to 2. We're just going to use the fact that this to this is 1 to 2, and we're also going to draw a line like that. And so, also we're going to see that this is 1 to 2, like that. Okay, let's just say that this area is 1. If this area is 1, since this triangle and this triangle have area ratio 1 to 2, this area is going to be 2. Looking at this triangle and this triangle, since these two are the same, then that means that they have the same area. So this is going to be 3, right? So that is 3. Looking at these two triangles, this triangle to this triangle's area ratio is going to be 1 to 2. So if this is 2, this is 4. So we have 4. And what we wanted at the start was this area to this area. So it's 3 plus 2 to 4. 3 plus 2 to 4 is 5 to 4. Yay, that's our answer. It's A. Number 11. In the figure below, WXYZ is a rectangle with WX equals 4 and WZ equals 8. Point M lies on XY. Point A lies on YZ, and WMA is a right angle. The areas of WXM and WAZ are equal. What's the area of WMA? Okay, so first thing to notice here, the areas of WXM and WAZ are equal, so that means that this area and, so this area and this area are equal. So that means that if we say that this length of AZ is x, then that means XM, that length will have to be 2x, because both of their areas will be 4x. Okay, so AZ is x, XM is 2x. But then that will give MY as 8 minus 2x, and AY as 4 minus x. Now what we need to see is similar triangles. We need to see that this triangle and this triangle are similar triangles because this is right angle, this is right angle. That means that this angle and this angle is equal, and this angle and this angle are equal. So that means these two are similar. And we know that thanks to this ratio, the ratio is going to be 1 to 2, like that. That means this to this ratio should be 1 to 2. So 4 to 2x is going to be 1 to 2. It's equal to 1 to 2. Sorry, 2 to 1. 4 to 2x is long to short, it's 2 to 1. So x is equal to 1, and what's the area of WMA? Since x is 1, we know that this is 2, this is 6, and these two are 1 and 3. So for WMA, we can just take the full rectangle and subtract 1, 2, 3 triangles, right? So rectangle subtracting 3 triangles is the whole thing is 4 times 8, so it's 32, minus this triangle is 4, minus this triangle is 4, minus that triangle, it's 9, right? So that's going to be 15, it's C. Number 12, a group of 100 students from different countries meet at a math competition. Each student speaks the same number of languages, and for every pair of students A and B, A speaks some language that B does not speak, and B speaks some language that A does not speak. What's the least possible total number of languages spoken by all the students? Okay, so if we have total of n languages being spoken in the room, each student speaks k languages each. That means that the total number of distinct combinations, because that's what we want, is going to be n choose k. N choose k, or like this, whichever you write it. And this has to be greater than or equal to 100, because there's 100 students. It's greater than or equal to 100. Okay? So we want nck to be greater than or equal to 100, and we want to minimize n. Minimize n. Okay, so k can be any value, but n wants to be minimized. So to minimize n, we want to have k closest to n over 2, because nck is greatest when k is half of n. Okay, so let's start with 9, the lowest value. So the biggest value when it's 9 is 9c4 or 9c5, any two. This is going to be 9, 8, 7, 6 over 4, 3, 2, 1. That's going to be 4, 2, and then 2. This is going to be 9 times 7 times 2 is 126, and that's over 100 already, so 9 is the answer. 13. Positive integers x and y satisfy the equation root of x plus root y equals root 1183, and what's the minimum possible value of x plus y? Okay, so first of all, we need to dissect 1183, and if you dissect hard enough, you get 7 and 169, and 169 is obviously 13 squared. So root 1183 is 13 root 7. And we want positive integers x and y to be like that. So that means to get the minimum x and y, we need to split this as evenly as possible. Since x and y need to be integers, we are going to separate them as 6 root 7 and 7 root 7. 6 root 7 is root 6 times 6 times 7. This is root 7 times 7 times 7. Since this is x and this is y, and we want x plus y, this is going to be 7 times 6 squared plus 7 squared equals 7 times 85, which is 595. And so that's our answer. It's B. Number 14, a dartboard is the region B in the coordinate plane consisting of points x, y, such that the absolute value of x plus the absolute value of y is less than or equal to 8. And the target T is the region where x squared plus y squared minus 25 squared is less than or equal to 49. A dart is thrown and lands at a random point in B. The probability that the dart lands in T can be expressed as m over n times pi, where m and n are relatively prime positive integers. What is m plus n? Okay, so let's just draw it quickly. First of all, this. The absolute value of x plus the absolute value of y is less than or equal to 8. That should be familiar because it's like a diamond region like that, which is 8, 8, minus 8, and minus 8. And so it's going to be inside there. For our target T, okay, so let's put that x squared plus y squared minus 25 squared is less than or equal to 49. And so if we take that squared away, it becomes x squared plus y squared minus 25 is between negative 7 and 7, right? Because 49 is 7 squared, which is also negative 7 squared. And so we can see that x squared plus y squared is between 25 minus 7, which is actually, 18, 18, and 25 plus 7, which is actually 32, right? So x squared plus y squared is between 18 and 32. That means that this region is actually like a donut shape, you know, between two circles. So this is a region that is between two circles, like that. So it's this region. And the first radius is root 32, and the second radius is root 18. Okay, so that region is entirely within the target. And so we want what is m plus n. Okay, we want the probability, right? So just probability is red area over the total area. So probability is going to be the red area. And what is the red area? It's the radius squared times pi. So that's root 32 squared times pi minus root 18 squared times pi over the whole thing, which is 8 root 2 times 8 root 2. That's 64 times 2. That is 72. 128. And if you're doing this, you're doing it the stupid way because it's here. These are the areas times pi. So that's 32 minus 18 times pi, which is 14 pi over 128. This is equal to 7 pi over 64. And so m over n times pi, we've got those here. So m equals 7, n equals 64. And if you add those, you get 71. And that's the answer, B. 15. List of 9 real numbers consists of 1, 2.2, 3.2, 5.2, 6.2, and 7, as well as x, y, and z, with y is between x and z. The range of the list is 7, and the mean and the median are both positive integers. How many order triples x, y, z are possible? Okay, so since our range is 7, we have 3 unknown numbers, and the maximum minimum values of the given numbers are 1 and 7. So we have 3 cases. The minimum is 1, which means that the maximum is 8. And when the maximum is 7, which means that the minimum is 0. And when both the minimum and the maximum are x and z. So minimum is x, and the maximum is x plus 7. Okay, so we'll divide it into 3 cases like that. So let's first look at this case. If the minimum is 1 and maximum is 8, then that gives us that z has to be 8. Since the mean has to be positive integer, that means 1 plus 2.2 plus 3.2 plus 5.2 plus 6.2 plus 7 plus x plus y plus z, which is 8 now. This is equal to a multiple of 9, right? Because there's 9 numbers and it should be integers, so multiple of 9. If you compute all that, that becomes x plus y plus, and then if you take out all the 9s in there, you are left with 5.8. So x plus y plus 5.8 has to be multiple of 9. Since x and y have to be between 1 and 8, they should be either 9 or 18. So this gives us that x plus y is 3.2, or x plus y is equal to 12.2. And let's try both of these cases. Let's move these away for now. Yeah, so we have 2 cases. Okay, if x plus y is equal to 3.2, we have 5, 6, 7, 8, 9 numbers, and minimum is 1, maximum is 8. For x plus y to be 3.2, we need the median to be one of x or y, and it can't be 3 because then the other would be 0.2, which is less than the minimum, and it can't be 2, right? Because if this was 2, then it would be 1.2, and then 2.2, which is over here, and there's no number to go in these two, so that means that this one is wrong. Let's try if x plus y is equal to 12.2. Okay, what if x plus y is equal to 12.2? Same thing, the middle number has to be x or y, and we can see that we can do, 2.2, 3.2, 5.2, and then we can have 6 like that as one of the x or y. Then if x is 6, y has to be 6.2, right? And so we have 6.2, which is y. We have one more 6.2, which is from here. And we have 7, which rounds it off nicely. So this is possible, right? So we have one case finished. And let's look at the other cases. If the maximum is 7 and the minimum is 0, then doing the same thing with that, except 0 plus, and then it's 1 plus 2.2 plus 3.2 plus 5.2 plus 6.2 plus 7 plus y plus z, because x is equal to 0 this time. Then that gives us that y plus z plus 6.8. This is going to be equal to a multiple of 9, which is either 9 or 18. So this gives us that y plus 2 is equal to 2.2 or 11.2. Setting up the 9 chairs, 9 places, like last time, 7, 8, 9. We have 0 and 7 at the very ends. If y plus z is 2.2, then we need one of those numbers to be here. Let's say this is 2 and it's 0.2 is here. So this is y, this is z. Then we will have 1, 2.2, which is less than 2. So that's not possible. So 2.2, that's, yeah. So 2.2, that cannot be. What if y plus z is 11.2? Then we have 0 and then 7, the same. And then we need one number to be at the middle. But then even if we split this to be less than 7, it's going to be 6 and 5.2 or 5 and 6.2, both of which are too close to 7. And so there's no way that there's a number possible to take this middle space. So both of these are impossible. What if we tried to make the minimum x and maximum x plus 7? Okay, I'll just wall these off. Okay, so we have two possible ways. First is that x is 0.1 and it reaches to 7.1. So from 0.1 to 7.1, then that means, that means that doing all this again, that means that 13 plus 1 has to be a multiple of 9. So this has to be 18 this time. So that means y must be 5. Let's see if that works out. We have the 9 places, 4, 5, 6, 7, 8, 9. And we have 0.1 to 7.1, and we have 5 in smack dab in the middle. Let's see if these fit. 1, 2.2, 3.2, 5.2, 6.2, and 7. Yes, they fit very well. So this is another solution. And the other way that it's possible is that it goes from 0.6 to 7.6. And then that way, if we do this whole thing again, it's going to become 14 plus y equals 9. And so that's going to give y is equal to 4. Let's try this thing again with 4 in the middle and 7.6 and 0.6 at the sides. Let's see if that works out. 4 and 0.6 and 7.6, and it all works out. So this is also a solution. And so we have 1, 2, and 3 solutions. The answer is C. Number 16, Jerry likes to play with numbers. Me too. One day he wrote all the integers from 1 to 2024 on the whiteboard. Then he repeatedly chose 4 numbers on the whiteboard, erased them, and replaced them by either their sum or their product. For example, Jerry's first step might have been to erase 1, 2, 3, and 5, and then write either 11 their sum or 30 their product on the whiteboard. After repeatedly performing this operation, Jerry noticed that all the remaining numbers on the whiteboard were odd. What is the maximum possible number of integer on the whiteboard at that time? Okay, so since the defining characteristic of the numbers are that it's odd, we can just think of the numbers in terms of are they odd or are they even. So from 1 to 2024, we have 1012 evens and 1012 odds. And since we want the maximum possible number of integers on the whiteboard, that means that we want the minimum number of these replacements. Because every time that Jerry does one of these replacements, he makes 4 numbers and he turns them into 1, right? So we want the fewest number of those things happening. And so to do the minimum number of replacements, what we do is we try to exterminate the even numbers only. So here we have 2 possible kind of scenarios with maximum even outing. So we can have changing even, odd to 1 odd number, which gets rid of 3 even at the same time. Or we can have even to 1 even by like adding or multiplying them like that, right? This also gets rid of 3 evens. But the difference is that this one has 0 evens left over. This one still has 1 even left over. That's why we're going to prefer this method and use just that on all the evens that we can. So if we use that as much as possible, 1012 divided by 3, because we need 3 evens for every replacement, that gives us that 1012 divided by 3. That's going to be 339. And then remainder will be 1. So that means that the number of odd integers will stay the same, because 1 odd became 1 odd. So the number of odd is going to be 1012, but we still have 1 even left over. So now we have 1 even and 1012 odds. And we need to get rid of that even. So we do one last operation, even, odd, odd, odd into an odd. And so that will make 1012 odds into 1010 odds, and then this into 0 evens. 1010 odds. Okay, so what's the maximum possible number of integers? That is 1010. It's A. Number 17, in a race among 5 snails, there is at most one tie, but the tie can involve any number of snails. For example, the result of the race might be that D is first, A, C, and E are tied for second, and B is fifth. How many different results of the race are possible? Okay, so we have, 5 scenarios. There's no ties, there's 2 people ties, there's 3 people ties, there's 4 people ties, or 4 snails ties, or all of them tie. So 0 snails tie, 2 snails tie. Obviously, because we can't have one snail tie with itself, that kind of goes against the whole definition of tie. We have 3 snails tie, we have 4 snails tie, and we have all snails tie, all 5 tie. 0 snails tie, that means we have 5 placements. 2 people tie means we have 2 like that, so this is 2 snails and this is 1 each, so we have 4 placements. 3 means we have 3 placements. 4 means we have 2 placements, and all means we just have 1 possibility, right? So all, that's just 1. 0, that's 5 factorial, which is 120. That is useful to remember. And 2 people tie. Okay, first we need to choose out of the 5 which 2 are going to be tied. So that's 5 choose 2 times, and then we have 4 different snails, right? Since all these are different, we just count one of that as like 1 snail. So that's going to be 4 factorial. This is going to be 10 times 24. This is 240. The same thing, 5 choose 3 times 3 factorial. This is going to be 10 times 6. This is 60. And this is going to be 5 choose 4 times 4 factorial. This is times 2 factorial. 2 factorial. This is going to be 5 times 2. This is 10. And so adding 120, 240, 60, 10, and 1 together, you get 431. So that is our answer. It's D. Number 18, how many different remainders can result when the 100th power of an integer is divided by 125? Okay, so we want the remainder when an integer is divided by 125. And note that 125 is 5 to the 3rd power, right? So we have 2 cases. The first case is when the integer is a multiple of 5. If it is a multiple of 5, then it's just going to be 5x to the power of 100 divided by 125. Obviously, the remainder is 0. If the integer is not a multiple of 5, that means that it's also going to be relatively prime to 125. And that means that we can use Euler's totient theorem. Euler's totient theorem. This basically says that if a and n are relatively prime, a to the power of phi of n is going to be congruent to 1 mod n. Okay, so this is only when a and n are prime. And that function here, that is the Euler's totient function. The Euler's totient function of 125, so phi 125 is going to be 125 times its only prime factor is 5. So it's going to be 1 minus 1 over 5. It's 125 times 4 over 5, 25 times 4, which is 100, which exactly happens to be our power. So that means that a to the power of 100 is going to be congruent to 1 mod 125. And this is when a and 125 is prime. That is when a and 125 is relatively prime. Okay, and since if it's not a multiple of 5, the integer and 125 is relatively prime, that means that the remainder is always going to be 1, right? So anyway, possible, the remainder is going to be either 0 or 1. So that's 2 possible ways. It's B. Number 19, in the following table, each question mark is to be replaced by possible or not possible to indicate whether a non-vertical line with the given slope can contain the number of lattice points, which is points both of whose coordinates are integers. How many of the 12 entries will be possible? Okay, first up is 0 slope. A non-vertical line with 0 slope, that just means a horizontal line. And can a horizontal line contain 0 lattice points? Obviously, yeah. Look at like y equals pi or something. Pi that does not contain any lattice points because y is always going to be pi. Next is 1 and 2, but then if you have a 0 slope, then if you have 1 point, then you will also have 2 points and 3 points and then infinitely many points, right? So these two are not possible, and infinitely many points, that's obviously possible, you know, like y is, I don't know, 3 or something. And non-zero rational slope, like y equals 3x. That is possible when it's more than 2, right? So it's possible. And if it's 0, it's also possible as well, because look at things like, you know, y equals 3x plus pi. Then your line doesn't go through any lattice points. But exactly 1 and exactly 2 is impossible like that. And lastly, let's look at irrational slope, you know, so if it's like y equals pi x or something, 0 possible, you know, like pi x plus pi, you know, that will give 0 lattice points. Exactly 1, that is also possible, because if you have y equals pi x plus like 3 or something, then that means that you are going to be only touching at 0, 3 and no other lattice points, right? So this is also possible. And more than 2, that's obviously possible. Sorry, no. Exactly 2 and more than 2, those will not be possible because it's not going to be able to keep a constant slope going, right? So these are both no. So we have, how many is it? 1, 2, 3, 4, 5, 6. It's C. Number 20, 3 different pairs of shoes are placed in a row so that no left shoe is next to a right shoe from a different pair. In how many ways can these 6 shoes be lined up? Okay, so no left shoe is next to a right shoe from a different pair. So that means no right, left, rights, and no left, right, lefts. So we have 4 possibilities. If we start with R, then we can go RR or we can go RL. But if it's RL, RLR is not possible, so we have RLL. If we go RR, we can do RRR or RRL. And since we already did 3 R's, we have no choice but to do LLL. Since we did RRL, we need to do RLL. We can't do RL, right? Because that's going to be LRL. But we can do LR, because that's possible. As for RLL, we can do RLLR or RLLL, right? And so this is going to give us R can do RL or RR, right? So these are the 4 possibilities. And if we say that left shoe is small a and right shoe is big A, this actually has 2 possibilities. We can do A, B, C, C, A, B, or A, B, C, C, B, A, like that. Those are 2 distinct arrangements, right? And for RRLLLR, we have only 1 possibility. That's going to be A, B, B, A, C, C. RLLRRL, that's going to be A, B, B, C, C. And RLLLRR, that's going to be A, B, C, C, B. I feel like I'm reading drum movements. So for each of these 5 possibilities, we have 6 possibilities because we have to order the pair A's, B's, and C's. So that's 3 factorial, which is 6. And we can multiply 2 because we can flip around the right and the lefts. And it's still going to be the same, right? And that's going to hold for all 5 of the pairs. Sorry, for all 5 of the scenarios. So like that, 6 times 2. And we just add them all together. It's 12 plus 12 plus 12 plus 12 plus 12, which is 60. And that's our answer. It's A. Number 21, 2 straight pipe circular cylinders with radii 1 and 1/4 lie parallel and in contact on a flat floor. The figure below shows a head-on view. What's the sum of the possible radii of a third parallel pipe lying on the same floor and in contact with both? Okay, so we have 2 possibilities. The first is that the third pipe is here, in between these 2. And the second possibility is that the other parallel pipe is this one, like that. My circle skills are not very good, but you can see what I mean, like that, right? So it's going to be something like that, and in contact with the floor, like that. We have 2 possibilities. Let's first look at this one, okay? So zooming in, since you have 3 circles like that, what's your first immediate urge? Center, center, and then drop down the lines like that, and like that, right? So since this radii is 1 and this is 1/4, but I don't like fractions, so let's just convert them into 4 and 1 for now, because all we really care about is their ratios, and we can just divide by 4 later, right? So if we say that this is 4 and this is 1, that means that that's 4, right? So that means this is 4 minus 1, which is 3. This is 4 plus, sorry, from here to here, that is 4 plus 1, which is 5. right? So it's 3, 5, and it's a right triangle. That means that this much here is 4, right? So that's 4. And what we're going to do is, using this little that little circle, like that, we're going to take its center like that, like that, and we're going to make 2 different triangles, one like that and one like this. Let's say that the radius is x. Radius of the small circle is x. Okay, so that means that this one here, that's going to be, okay, I'll draw it here. So we have that and we have that. This one here is going to be 4 plus x. 4 plus x. This one is going to be 4 minus x. 4 minus x. And so that means this is going to be square root of 4 plus x squared minus 4 minus x squared, which is basically 16x. So that's going to be 4 root x. And in the same way here, this is going to be 1 plus x. This is going to be 1 minus x. And so this is going to be root of 1 plus x squared minus 1 minus x squared, which is 2 root x. And so putting those together, you get 6 root x. You get 6 root x. And that is equal to 4. Yay. So you get root x equals 2 over 3, and x equals 4 over 9. But here, this x is not the actual radius. Why? Because we used 4, 5, 1 like that, which is 4 times the actual value, right? Because the actual radii is 1 and 1/4. So we need to divide this by 4 again. So we get 1 over 9. So small radius is 1 over 9, like that. And let's do the same thing for the big one too. We can do the same thing for the big one as well. We can keep thinking of it as 4 and 1, because we'll just be doing that again. But then this time, let's try, so it doesn't really look like it, but let's say that this one is bigger than the others, a little bigger than the others, right? Then that means that we're going to have like a slight little triangle probably. So we're probably going to have a small triangle like that, which goes like that. And we can compare that to this triangle, right? So this time it's a subtraction. This black length minus 4 is equal to this green length. Let's do it again. Set this as y this time. So this length is going to be 4 plus y, and this is going to be 4 minus y. And so same thing, this will be 4 root y. 4 root y using Pythagorean theorem. For the green one, this is going to be 1 plus y. This is going to be y minus 1. Oh, I'm sorry, I should have said y minus 4. Y minus 4. But then this is still the same, because y minus 4 squared is equal to 4 minus y squared. And here this is going to be 2 root y. But then here we're going to subtract this from this. So 4 root y minus 2 root y, that's 2 root y, is equal to 4. This 4. This gives us that y is going to be equal to 4. But since this was also using values that were multiplied by 4, we need to divide that by 4, right? So large radius is 1. Large radius is 1. And 1 plus 1 over 9, this gives us 10 over 9, which is here. It's C. Number 22, a group of 16 people will be partitioned into 4 indistinguishable 4-person committees. Each committee will have 1 chairperson and 1 secretary. The number of different ways to make these assignments can be written as 3 to the power of r times m, where r and m are positive integers and m is not divisible by 3. What is r? Okay, so if we want to write the number as 3 to the power of r times m, but m doesn't have 3, that means that we just want the number of 3's in the final value. For us to divide 16 people into 4 committees, so that means that it's 16 factorial divided by 4 factorial times 4 factorial times 4 factorial times 4 factorial. But then since they're indistinguishable, that means that we have to divide by 4 factorial again, because there's the ordering of these committees. And then since we want a chairperson and a secretary, so for each group of 4, 1 chairperson and 1 secretary, that's going to be 4p2, which is going to be 4 times 3, which is 12. So this is this times 12 to the power of 4, because there are 4 committees. So this gives us 16 factorial over 4 factorial times 12 over 4 factorial to the power of 4, right? This gives us, this is 12 over 24, so that becomes times 1 of 2 to the power of 4, but we're interested in the number of 3's, right? So there are no 3's here, there's 1 3 here, and 16 factorial has how many 3's? We have 3, 6, and 9 has 2 3's. We have 12, and we have 15, so we have 6 3's. 6 3's divided by 1 3, so 6 minus 1, this gives us 5 3's. So 5 is the answer, it's A. Number 23, the Fibonacci numbers are defined by f1 is 1, f2 is 1, and fn is equal to fn minus 1 plus fn minus 2 for n is greater than or equal to 3, as we know. What is this? Okay, so what we're doing is finding patterns. Let's just try and write out the first Fibonacci numbers. The Fibonacci numbers for n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be, we're starting at 1, 1, and then it's 2, 3, 5, 8, 13, 21. Is it 34? And it's 55, like that, right? And so let's just try these one by one. f1 over f2 is going to be 1 over 1. And then it's going to be 3 over 1. And then it's going to be 8 over 2, 21 over 3, and 55 over 5, and so on, right? And we can see that this is 1, 3, 4, 7, 11, and so on. Do you notice a pattern? This sequence of numbers itself has like Fibonacci-like qualities, right? Because the next number is always the sum of the previous two, right? 4 is 1 plus 3, 7 is 3 plus 4, 11 is 4 plus 7, like that. And we can assume that this trend will continue, right? So we need 1, 2, 3, all the way to 10. So we need 10 of these numbers. So starting at 1 and 3, 1, 3, 4, and then the next is 7, 11, and then the next is 18, and 29, plus 47, plus 76, plus... and then it's 123. So we get, this is 4, 8, 15, 26. These two, we get 44, 73, 120, and then 196. And then finally 319. That is our answer. It's B. Number 24, let PM be this thing. How many of the values P 2022, 2023, 2024, and 2025 are integers? Okay. So here, since this is 2, 4, 8, and 8, if m is even, then that means that p of m is going to be integers right away, right? So that means these two are integers automatically. What if m is odd? So if m is odd, then let's put them as 2n plus 1, because that's going to be an odd number if n is integer. And so if we put those in there, it's going to be 2n plus 1 over 2 plus 2n plus 1 squared over 4 plus 2n plus 1 to the 4th power over 8 plus 2n plus 1 to the 8th power over 8. And since the 2n part is even, if we expand these out, all of these will become integers except for here, and then 1 squared over 4, 1 to the 4th power over 8, and 1 to the 8th power over 8. So that's going to be integer, some large massive integer, plus 1/2, plus 1/4, plus 1/8, plus 1/8. Guess what? This is equal to 1. Plus large massive integer. Since this is 1, this whole thing is going to be 1 plus large massive integer, which is an integer. Even if it's odd, it's going to be integer. That means all of it is going to be an integer. All 4 is an integer. It's E. Last problem, number 25. Each of 27 bricks of right rectangular prisms has dimensions A by B by C, where A, B, and C are pairwise relatively prime positive integers. These bricks are arranged to form a 3 by 3 by 3 block as shown on the left below. A 28th brick with the same dimensions is introduced, and these bricks are reconfigured into a 2 by 2 by 7 block shown on the right. The new block is 1 unit taller, 1 unit wider, and 1 unit deeper than the old one. What is A plus B plus 3? Okay, so first we had 3A, 3B, and 3C sides. Next, after that, we got 2B, 2C, and 7A sides, which is equal to 3A plus 1, 3B plus 1, and 3C plus 1 respectively. So if we rewrite that, we get, 3A plus 1 becomes 2B, 3B plus 1 is the same as 2C, and 3C plus 1 is the same thing as 7A. So if we add these all together, we can see that 2B cancel out leaving 1B, 2C cancel out leaving 1C, 3A and 7A cancel out leaving 4A, so B plus C plus 3 is equal to 4A. And since we want A plus B plus C, if we change it into that form, A plus B plus C is going to be equal to 5A minus 3. Okay, but then since the answer is 5A minus 3, this means that it must have remainder 2 when divided by 5. So it's in 5n plus 2 form, right? 5n plus 2 form. And of these choices, the only one that is in 5n plus 2 is E. So that's our answer. That was the 2024 AMC 10B, and thank you for watching.